Alright, in Module 3, Lesson 8, okay, we're going to start looking at similarity, and we're going to be describing that. So we have these two figures, okay, they look similar, but we cannot just say that a dilation alone will prove similarity between these two figures. They look like they're the same size, different shape. To prove that they are similar, you would have to show how they could be the same size by dilating one of the figures, and then you would also have to show that they were, you could prove congruence, that they could line up with one another. Before we did that, we'd have to, 1, find a scale factor, and 2, then perform the congruence in a center. Okay, so we're going to jump into this with example 1. Okay, so in the picture below we have triangle ABC that has been dilated from center O by a scale factor of 1/2. It's noted by A prime, B prime, C prime, which is right here. So ABC, A prime, B prime, C prime. We also have triangle A prime prime, B prime prime, C prime prime that is congruent to triangle ABC, or A prime, B prime, C prime. So this little symbol right here means congruent. And then we're going to talk about the symbol for similarity in a little bit. And it asks us to describe a sequence that would map triangle A prime prime, B prime prime, C prime prime onto triangle ABC. Okay, so what we're going to do is we're going to describe a dilation followed by a congruence. Okay, so these two things here are similar. Okay, so because they are, congruent. So because they're congruent, if I dilate this one, okay, by the reciprocal of how to get from this one to this one, there's original scale factor was 1/2. So to dilate by the reciprocal, our scale factor would be 2. Okay, so I would dilate triangle A prime prime, B prime prime, C prime prime from center O with scale factor R equals 2. That's what I would do first. I would dilate it. So now I'm going to do that. So A prime prime is at 11, 4. So if I multiply that by 2, it would be at 22, 8. B prime prime is at 13, 5. So if I multiply that by 2, it would be 26, 10. And then the C prime prime is at 15, 3. If I multiply that by 2, it would be 30 and 6. So now that we've dilated it, our shape is the same size as ABC. So now we would just describe how to get A prime prime, B prime prime, C prime prime, the one we drew over here, onto ABC. So we have this one, purple one, and we want to move it here. So what I'm going to do is I'm going to look at translation, at lining them up first, and I think that you'll always want to use translation first. Okay, so we're going to translate triangle A prime prime, B prime prime, C prime prime, and then we're going to look at that. So I just want to see if I can move A, B, and C at one time, and it looks like they're in the same orientation, they're facing the same direction. So because they are facing the same direction, I should be able to just translate them over. So I would just move A prime prime along the x-axis and then down, or along the parallel to the x-axis and then parallel to the y-axis. So what I did was move it, okay, x, because I went left, 1, 2, 3, well, let's see, 22 to 2, left 20. So I could say x minus 20 because we went to the left. And we went down 2, so I could say y minus 2. Okay, so translate triangle A prime prime B prime prime C prime prime with, okay, and this is one way to write. I'm going to show you two different ways. With x minus 20, y minus 2. Or you could say left 20, down 2. Okay. So that would be our sequence to move triangle to show a sequence that mapped A prime prime B prime prime C prime prime onto triangle ABC. Okay, so that would be our sequence. Because we can map that and show that sequence that they are could line up, that means that triangle A prime prime B prime prime C prime prime is similar to triangle ABC. This little symbol here means similar. Oh. Okay, so you're going to describe your sequence and then you have to tell that they're similar. Okay, and now I'm going to quickly describe a few on my own, okay, that you just watch with me, and then we'll go through this. I don't think I'm going to do all of them, but we'll see. Okay, so we're going to start with this one, and we want to prove, okay, we have triangle DEF, which is here. We have triangle D prime, E prime, F prime, which is here, and we have D prime, prime, E prime, prime, F prime, prime, which is congruent to D prime, E prime, F prime. So the big ones are congruent. D prime, prime, or D prime, E prime, F prime was a dilation of DEF. Okay, so I want to prove that triangle D prime, prime, E prime, prime, F prime prime is similar to triangle DEF. Okay, so I want to go backwards. So if we look at this, our scale factor, we need to identify our scale factor first. Okay, so from F to F prime, it was at 2, 0, and it went to 6, 0. So it looks to me like we multiplied by a scale factor of 3 originally. Negative 2, 1 went to negative 6, 3 multiplied by 3. So our original scale factor was 3. So we're going to use the reciprocal to dilate this triangle. So we're going to say dilate triangle D prime prime E prime prime F prime prime from center O, you got to have that, with scale factor R equals 1/3. Okay, that's the reciprocal of 3. So when we do that, F prime prime doesn't move. 1/3 of negative 12 and 3 would be negative 4, negative 1. D prime prime, E prime prime. 1/3 of 9, negative 9 would be negative 3. And 1/3 of 6, negative 6 would be negative 2. Okay, then we would have to prove congruence, that they overlap. So I would then translate this purple triangle. Okay, triangle D prime prime, E prime prime, F prime prime. 2 to the right, right there. So x plus 2, and we don't change the y, okay, or right 2, okay. So then it would be, let me draw it in with another color. Here, and we could reflect it over because E is at the bottom and we want it to go to the top, so then we would reflect triangle D prime prime E prime prime F prime prime over the x-axis, so that E prime prime coincides or lines up with E, and then that would prove that triangle D prime prime E prime prime F prime prime is similar to triangle D E F. Okay, so here it would be a reflection. There's no rotation. You would just reflect over the x-axis here. Okay. Then we're going to move on to another example. That's a reflection, that's a reflection. Okay, so we want to prove that triangle ABC and A prime, B prime, C prime are similar. Okay, so the first thing I would do is normally you would want to dilate the image. If I dilate, oh, I can. I'm going to dilate A prime, B prime, C prime. I want it to line up with ABC, line up with this. So I'm going to dilate by scale factor. This is at -2, or 2, -2. This is at -2. So this is, so when it's on a grid, okay, and they're on the grid lines, you can see this length is 1 and this length is 2. This length down here is 3 and this length up here is 6. So to get them to be the same size, I would dilate by a scale factor of 1/2. So my scale factor is going to be 1/2 to get ABC to be the same size as A prime, B prime, C prime. Okay, so dilate triangle ABC from center O with scale factor of R equals 1/2. So -1 A B C. So this is what that would look like. And then I'm going to have to do some translation and reflection. Okay, no rotation will be needed for this one. So we could translate, I'm going to do B to B prime so that a side lines up. So 1, 2, 3, 4 down, 1, 2, 3 right. So that would be 4 down, which would be y minus 4. And then 3 right, which would be x plus 3, because it went in a positive direction. So that would be translate triangle ABC with x plus 3, y minus 4, or down 4, right 3. So then my shape would be here, and then I would just reflect triangle ABC over side A prime, B prime, so that C and C prime coincide, which just means line up. So then triangle ABC is similar to triangle A prime, B prime, C prime. And before we jump into that, I want to talk about this last one real quick. Okay, so the question is figure A similar to figure A prime? I can't get this closer. A similar to A prime. Obviously, you guys can look at this and tell that those figures are not similar because the corresponding sides are not in proportion. So if we see these 6 and 8, that's in proportion of 2. 24 and 12, that's in the proportion of 2. But then there is no straight connecting them here. There's no line. So then the sides are not in proportion. Okay. So now we're going to go into the exercises. Okay. So triangle ABC was dilated from center O by a scale factor of R equals 1/2. The dilated triangle is noted by A prime, B prime, C prime. Okay, another triangle A prime, prime, B prime, prime, C prime, prime is congruent to triangle A prime, B prime, C prime. So these two are congruent. This one is a dilation of the original. Okay. Describe a dilation followed by a basic rigid motion that would map triangle A prime, prime, B prime, prime, C prime, prime onto triangle ABC. Okay, so we're going to start with the dilation. It tells you dilation followed by a basic rigid motion. Okay, so a dilate triangle A prime, prime, B prime, prime, C prime, prime, because we're wanting to move it back to ABC. Okay, so dilate triangle ABC from center O go work with a scale factor of R equals the reciprocal of 1/2, which is 2. Okay, so I'm going to take this point and I'm going to multiply each coordinate by my scale factor. So A prime prime was at 3, 2. So 3 times 2 is 6. And 2 times 2 is 4. So A prime prime. B prime prime is at 4, 3. So I'm going to multiply that by 2 as well. So 8, 6. 5, C prime prime is at 5, 1, so at 10, 2, and we get this triangle. And this says followed by the rigid motion, so you're going to only do one thing. So it's, if you look at this, the orientation of these figures is the same. They're facing the same direction. So the rigid motion that would move it over there would be a translation. So we're going to translate triangle ABC. And I'm going to use this. And I'm just going to do B prime prime to B. So I'm going to go up. One, two, three, 4, up 4, or that would be y plus 4 because we went up. And then I'm going to go left 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So then it would be left 12 or x minus 12 because we went in the negative direction. Translate triangle A prime prime, B prime prime, C prime prime, sorry, with x minus 12, y plus 4, or up 4, left 12. And then once they're lined up, that proves that they are similar. So triangle A prime prime, B prime prime, C prime prime is similar to triangle A, B, C. Alright, let's go on to number 2. Describe a sequence that would show triangle ABC is similar to triangle A prime, B prime, C prime. So first of all, you have to figure out the scale factor. Okay, so we know the distance from A prime to B prime equals the scale factor times the distance from A to B. So the distance from A prime to B prime is 1, 2, 3, 4, 5, 6 times our scale factor, and the distance from A to B is 2. So we divide by 2. Our scale factor would be 3. So we would take 2 times 3 and get 6. Okay, so I'm going to dilate the original figure by a scale factor of 3 because we're wanting to prove this one is similar. So dilate triangle ABC from center O with a scale factor of R equals 3. Okay, so obviously when I dilate this, it's going to be too big. So then I'm going to do it anyway. So I'm going to do 3, or C. So C is at negative 3, 0. If I multiply that by 3, it would be at negative 9, 0. C. Everybody good with that? Then we would just talk about connecting those points and what that would look like. B obviously is going to be up there, 9 way up here, and A is going to be way up here. It's going to be this huge, crazy shape. Okay? So then we're going to do a translation. So I would translate triangle ABC, and because C is on the grid, I'm going to use it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the right. So right 10 or x plus 10. And then I'm going to translate it 1, 2, 3, 4, 5 down, down, 5 or y minus 5. Okay, so then I'd have it here, and then it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, like this, something crazy like this. So then we would obviously need to rotate that. I guess I should write this out. Translate ABC with x plus 10, y minus 5, or write 10 down 5. And then we're going to need to rotate it around C prime because it's connected here. And I'm going to say, because this is on the grid lines, I know that this right here is a 90-degree angle, 90 degrees, so that side AB and side A prime, B prime coincide, which just means overlap. And then that proves that triangle ABC is similar to triangle A prime, B prime, C prime. Okay, are the two triangles shown below similar? If so, describe a sequence that would prove triangle ABC is similar to triangle A prime, B prime, C prime. If not, state how you know they are not similar. Okay, so we need to see what our scale factor is. So to go from one to the other, we know that the distance from A prime C prime equals the scale factor times the distance from A to C. So A prime C prime is 12 equals our scale factor times the distance from A to C, which is 18. We divide both sides by 18. Our scale factor is 2/3. And that happens with the other two sides. 4 divided by 6 simplifies to 2/3. 10 divided by 3 also simplifies to 2/3. So because we have the same scale factor, okay, and they look like the angles are the same, then we would do this. So because they have the same scale factor, the corresponding sides are in proportion and equal to the scale factor. So the corresponding sides are in proportion and equal to the scale factor. And I'm just going to abbreviate there. Okay? So then we'll do some mapping, proving some congruence. So you would first dilate triangle ABC from center O, which is somewhere, by the scale factor R equals 2/3. Then you would translate triangle ABC along vector A prime, and then rotate triangle ABC around A prime, D degrees. So when it is on a grid, we can see that it's a lot more specific in our description, and you have to be just very descriptive. If you just put dilate, translate, rotate, you're going to get a 1 out of a 3. You got to give me all the information. When we've been talking about that from day 1. Okay, down here, you don't have to do quite as much because you already know your scale factor. You come up with some center O. You translate it along a vector instead of worrying about how much exactly, and you rotate it around a point, and you don't have to worry about the amount of degrees. Okay, and then number 4, okay, number 4. Okay, it says, are the two triangles shown below similar? If so, describe a sequence that would prove they're similar. If not, state how you know they are not similar. Okay, so we need to determine if their corresponding sides are proportion and have the same scale factor. So we got to do the definition of a dilation. The distance from A prime to C prime equals the scale factor times the distance from A to C. So this is 4 equals R times 3. So 4/3. Okay. So R equals 4/3. If we did that with the distance from C prime to B prime equals our scale factor times the distance from C to B. This is 8 equals R times 6. Divide both sides by 6. R equals 4/3 again. And if we did it with the last side, the distance from A prime, B prime equals our scale factor times the distance from A to B. So it would be 10.67 equals some number times 8. So divide by 8. R equals 1.3, which is the same as 4/3. Okay, so yes, they are in proportion. With corresponding sides, okay, and scale factor. So then we would describe that. So of course you're going to do your dilation first. So we're going to dilate triangle ABC from center O with the scale factor we found. Scale factor R equals 4/3. Okay, and it's going to make it bigger. And I'm not going to try to dilate that because the points are not on the grid lines, okay, so it would just get bigger. And then I would just translate, okay, because they're not on the grid lines, so I would just use a vector. I would then translate C to C prime. So I translate triangle ABC along vector C, C prime. And then it would look something like this. If I could draw. No, it wouldn't. Ignore that. And then I would rotate, because A would be down here and B would be up here, so I would have to rotate around center C prime, and it's going to be 180 degrees because you're just going to rotate it around this line. And then that proves that triangle ABC is similar to triangle A prime, B prime, C prime.